Hi everyone. In this video we're going to talk about part 1 of your project and this concept of explainable machine learning. First we're going to talk about what I've already provided you, what I've already done, and then we're going to talk about something called the sliding window algorithm for explainable machine learning. Let's see, in this video we won't be going over any code. In the next video I'll go into the details of code and what you actually have to program for the assignments. Okay, so what's already been done? Well, we started, or remember that our goal is given the title of an article. Given the title of an article, we want to be able to predict the host name that the article is published at. And so I've already trained a machine learning model that does this for you using this command right here. So again, this is a bash command or a terminal command, and we know that because it starts with the $sign over here. And you might not have seen these backslashes before, but what these backslashes mean is that all of these are actually one command. That normally when we run a command in the terminal, as soon as we press the enter key, the command gets executed. But if we have a backslash as the very last character of our line, that tells the terminal not to run the command right away, but to wait for us to type in more values on subsequent lines. So each of these flags, each of these hyperparameters is getting passed into names.py. And this names.py file is just a continuation of what we've been working on in the past two homework assignments, homework 6 and homework 7. I wanted to keep the same name of the file to emphasize that the recurrent neural networks that you developed for those two homework assignments, they still will work for this assignment right here, where we're working on what seems like a totally different problem. We're analyzing newspaper articles now instead of people's names. But the same code still works. Let's see. So like 95% of this code is the same as the last assignment. I've added a couple of new sections though for loading the data in this new file format, this JSON-L format. The model that we're looking at is a relatively big model. It has 512 hidden layer size, and it has a total of 8 hidden layers. So it's much bigger than the models we were using for the names task in homework 7 and 6. And it makes sense that we would have a bigger model now because our problem is significantly harder to do. We have much longer inputs, and they're much more complicated because they're actual sentences rather than just a single word. Because the models are more complicated now, I've also added these two flags to the models, and I'll talk about those more in detail when we look at actual code. But this ResNet flag adds residual connections, those skip connections between layers of the recurrent neural network, and those are important for model training, just like they were important in the ResNet CNN. For ImageNet. And I added this dropout hyperparameter as well. If you remember, dropout is for regularization of machine learning models. And because we have a very large machine learning model, because our model is very complex, it is very likely to also overfit the data, and the dropout regularization parameter helps reduce overfitting. Okay, so again, you do not have to run a command like this yourself. This command takes a fairly long time to run. I let it run for 2 days on my GPU system, and so you can just download the results of my running the model. Again, the wget command just downloads this file, so if you don't have wget on your computer, you can download it manually through Firefox. But you'll need to create a models folder, put the gzipped model archive inside of the models folder, and then extract the gzipped model archive. So I know that a lot of you were having problems on homework 6 extracting some of my tar files. So please try to do this step as soon as you can so that if you do have problems on this step, we can get those resolved while you still have time to complete the assignment. Okay, the last thing that you'll need to do is create a folder called Explain Outputs in your project directory. Once you've completed all of those steps, you're ready to actually start the inference. And so this is the command right here, which we'll be running to do the inference. And in order to show you what that output looks like, I'm going to take this terminal and again swap it over to there. Boink. And now I'm going to run that command. And it'll take a second to run. Here's the sort of output. So notice that there's 300,000 lines. There's 11,447 different categories. Each one of those categories is a different host name that we're trying to predict. And after it prints out that it's done warm starting, whatever I type in right now is the article title that the model will try to predict on. So let's create a made-up title that says a coronavirus pandemic is spreading to Claremont. And these are the predictions, the top 20 predictions that our model thinks that an article with this headline might have been published at. So ABC in Australia, that's interesting, and then Insider, Business Insider, and Yahoo News, and so on. In order to exit out of this program, you'll have to press Control and D at the same time, and that will return you back to the terminal prompt. Let's see, so when we have a program like this, where you normally type in the inputs, we say that the program is getting input from standard in. STDIN is the abbreviation for standard input. And we can use what's called input redirection to make working with these programs a little bit simpler. In Bash, there's many ways to use input redirection, so I'm going to show you some of those right now. You may have seen before, so here is the same command that I was previously running up here. You may have seen before input redirection with a single left arrow like this. What I'm going to do though is with a 3 left arrow. So in Bash there's 3 types of input redirection: the single arrow, the 2 arrow, and then the 3 arrow. And then what the 3 arrow does is whatever I type over here in quotation marks will get passed as the input into the program. So I'm going to copy and paste coronavirus pandemic is spreading to Claremont into this string right here, hit enter, and now this will automatically get typed into the program for us so we don't have to type it manually. Let's just double check to make sure that we get the same output that we had before. And we do. So we still get this ABC Australia Insider, Business Insider, and Yahoo News as the top 4 predictions of where this article title might be published at. Okay, so now I'm going to take our Firefox and move it back into the big window. Okay, and so we've talked about up to here so far. And so now I want to see some examples of what our model's capable of. And so the first is that geographic similarity that we talked about before. And so, this Australian newspaper has actually published an article with this title right here, saying sick Qantas passenger at Melbourne airport sparks coronavirus fears. And we can run our inference algorithm on this we can run our inference algorithm on this title using the command this right here. And so it's exactly what we had just typed into the terminal, where it's Python 3 names.py and the infer flag, and then the model we're warm starting with, And then again, this is the triple left arrow to do input redirection. And then inside of quotation marks over here is the string of the title that we're looking at. And here are the top 5 predictions that we get. And so that's great. We get the news.com.au as the top prediction. It's great because that's where it was actually published at. But notice that we also get some other Australian newspapers right here and right here. And so that's great that our model thinks that other Australian papers might be publishing titles like this because it's talking about Melbourne. Makes sense that Australian papers would publish a lot of things about Melbourne. We're also getting the dailymail.co.uk, so that's a British paper. Also, so part of the Commonwealth, makes sense that they would be talking a lot about Melbourne as well. And then news.yahoo.com, a very widely read thing. Makes sense to me that all these things would publish a title like this. So next, so we can say all of these are somehow similar in the geographic topics that they talk about. The next example is topical similarity, and so I want to look at this website, virological.org. This is a discussion forum where doctors and biologists post their own analysis of different viruses. So it's kind of like a Facebook or a Reddit or a Twitter for people who study viruses. And so understandably, they would be talking a lot about the coronavirus on this webpage, but they're going to be talking about very cool technical details about the coronavirus. And so here's one article that I saw published there. nCoV's relationship to bat coronaviruses and recombination signals. No snakes. No evidence the 2019 nCoV lineage is recombinant. So that sounds very technical to me. That sounds like the kind of thing that I would expect doctors to say and to each other and to write about, but probably not for something like, let's get that away. Probably something like news.yahoo.com. They're targeting a much more general audience than an article like this would be targeting. And so we can run our inference algorithm again, and here are the top 5 predictions that we get. So virological.org, that's great. And then we also get this contagiontracker.com. That's another website that's geared towards more like medical actual knowledge things. So that makes sense that would be closely related to virological.com. And then we get Business Insider, and then this en24.news. And so these are all more generalist publications, but the fact that they're associated with a very technical title like this leads me to think that they might be running more technical stories than, say, news.yahoo.com. And so that's, I think, an interesting result that we have so far. Let's see, so now let's look at political biases. So Breitbart.com, famous conservative news source, and they ran this story a couple of days ago. Coronavirus panic partly driven by anti-Trump hysteria. Polak is the name of one of the leading editors at Breitbart. And so again, we can run our model by putting the title of our article in quotation marks over here with the input redirection, and these are the outputs that we get. So in this case, notice that Breitbart is not one of the top predictions, but all of these other top predictions are fairly conservative news sources, very similar in spirit to Breitbart.com. So USSA News, Infowars.com, probably the most famous one in this list, and then these are some more conservative-ish blogs. And the fact that, say, So I had never heard of this blog before, but the fact that this was getting kind of confused with Breitbart.com gives us a pretty strong indication that this is in fact a fairly conservative blog. Okay, but this is all great that our model gives us sort of crude way in order to be able to compare the political and topical and geographic biases of our models. But is it really doing that? We're not really sure because we don't have good explanations about why our model decided that these were the top 5 most similar or the top 5 best predictions for this particular title right here. And without an explanation about why, who knows why it was doing this prediction? It could be that this prediction was done entirely based on syntax and not at all based on semantics. So remember that at the syntactic level, that's just, or when we consider a string on the syntactic level, that's just looking at the characters by themselves or just looking at the words by themselves without looking at the meaning behind those words. So here, one of the things that we have is that we have capital letters starting each one of these words. And it might be the case that all of these news articles or all of these web pages just also use that convention of using capital letters at the beginning of words. And that's why the model decided to predict that these classes were good classes for this string. And if that's the case, then for some tasks that would be useful, but it doesn't really help us in the task of determining political similarity. So what we need to do is somehow prove that our model is actually looking at the semantics of this string and not the syntax of this string. And that's what the model explanations are going to do. They're going to show us how to, or they're going to sort of give us a way to prove that our model is looking at semantics instead of syntax. And it will explain what type of semantics we're looking for. And we'll use a very simple algorithm called the sliding window algorithm to do this. Let's see, I think this video's gone on long enough, so I'm going to stop this and do the sliding window algorithm in a new video.